In this example video, we're going to compute different types of means for a data set. So for our first example, we're going to compute the arithmetic mean for this set of data, which represents the number of text messages a person sends in a day. So you can see that I've already lined the data values up from smallest to largest, which is pretty nice. And also not significant when finding the arithmetic mean. So if you remember from the text, the arithmetic mean, which is commonly known as an average, this is computed using the formula the sum of your data values divided by the number of data values that you have. So it's, like I said, commonly known as an average, but this is known as the arithmetic mean. So all we're going to do is add up all these data values and divide by the number of them that we have. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. So the arithmetic mean for this data set is 25.5 exactly. So on average, it looks like a person sends about 25.5 text messages. So there are other types of means that we can compute, and one of those types is a trimmed mean. So I'm going to look at the exact same data set as a previous example, but this time we're going to find the 10% trimmed mean. So recall from the text that when you're trimming your data set, okay, and this says we're going to trim 10%. We're not just going to trim 10%, we're going to trim 10% of the lowest data values and 10% of the highest data values. Once we trim the highest and lowest 10% off from our data set, we'll just compute the arithmetic mean of what's remaining. So the first thing I have to do is actually find out how many data values is 10% of my total data values. So I have 10 data values, and I need to know 10% of 10, so I'll multiply by 0.1 to find out the number of data values that is 10%. And of course, this is just 1. So one data value is 10% of the total number of data values I have. And since I'm trimming 10% off the bottom and 10% off the top, I will take off one data value from the bottom and one data value from the top. Okay. So we're going to trim one data value from the top and from the bottom. And what's left is what I will compute the mean of. Is that value. So what if I look at a similar problem, a 10% trimmed mean with almost the same data set? Okay, so what I've done is I've replaced 42 with 490. So if I want to, again, compute the 10% trimmed mean of this data set, I'll execute the same process, right? 10% of the lowest values, 10% of the highest values. In this case, I have 10 values. Okay, so I will trim one data value from below, one data value from above, and I'm left with these values right here, which you can see from the previous example are the exact same numbers. So I'm going to have the exact same computation. So what this shows us is that the trimmed mean is considered a resistant measure, and it's resistant because it's not affected by outliers. When I severely changed one of these values to be an extreme outlier compared to the rest of the data set, you can see that that outlier was trimmed off and not even considered when computing this mean. So we consider the trimmed mean to be a resistant measure because it's not affected by outliers.